be wrong.
And even in our own universe, quantum mechanics says there's a chance that things we'd ordinarily think of as impossible can actually happen. For example, there's a chance that particles can pass right through walls or barriers that seem impenetrable to you or me.
There's even a chance that I could pass through something solid, like a wall. Now, quantum calculations do show that the probability for this to happen in the everyday world is so small that I'd need to continue walking into the wall for nearly an eternity before having a reasonable chance of succeeding. But here, these kind of things happen all the time.
You have to learn to abandon those assumptions that you have about the world in order to understand quantum mechanics. In my gut, in my belly, do I feel like I have a deep intuitive understanding of quantum mechanics? No.
And neither did Einstein. He never lost faith that the universe behaves in a certain and predictable way. The idea that all we can do is calculate the odds that things will turn out one way or another was something Einstein deeply resisted.
Quantum mechanics says that you can't know for certain the outcome of any experiment. You can only assign a certain probability to the outcome of any experiment. And this Einstein disliked intensely. He used to say, God does not throw dice.
Yet experiment after experiment showed Einstein was wrong, and that quantum mechanics really does describe how the world works at the subatomic level.
So quantum mechanics is not a luxury, something that you can do without. I mean, why is water the way it is? Why does light go straight through water? Why is it transparent? Why are other things not transparent? How do molecules form? Why are they reacting the way they react? The moment that you want to understand anything at an atomic level, as non-intuitive as it is, at that moment you can only make progress with quantum mechanics.
Quantum mechanics is fantastically accurate. There has never been a prediction of quantum mechanics that has contradicted an observation. Never.
By the 1930s, Einstein's quest for unification was floundering, while quantum mechanics was unlocking the secrets of the atom. Scientists found that gravity and electromagnetism are not the only forces ruling the universe. Probing the structure of the atom, they discovered two more forces. One, dubbed the strong nuclear force, acts like a superglue, holding the nucleus of every atom together, binding protons to neutrons. And the other, called the weak nuclear force, allows neutrons to turn into protons, giving off radiation in the process. At the quantum level, the force we're most familiar with, gravity, was completely overshadowed by electromagnetism and these two new forces.